Now I'd like to introduce you to the chairman of Opalytics, Dr. David Simchi-Levi. As background, before I turn this over to him, Dr. David Simchi-Levi is a renowned operations research and supply chain expert, engineering systems professor at MIT, and chairman of Opalytics and OPS Rules. He was the co-founder of Logic Tools, a supply chain software company that became part of IBM in 2009, and between 2006 and 2012, he served as the editor-in-chief of Operations Research, the flagship journal of Informs. He is the author of Operations Rules and co-author of Designing and Managing the Supply Chain, The Logic of Logistics, and several other publications. With that, thank you again for joining us today, and we'll begin in just a moment as I switch control to Dr. David Simchi-Levi.
Welcome, everybody. My name is David Simchi-Levi. I'm on the faculty at MIT. Today, I will give this presentation together with Pete Cacciopi from Opalytics. A little bit about our background. I came to the US about 30 years ago for 1 year only, and it has been a very long year. In 1996, together with Pete and others, we started a software company focusing on supply chain planning. The company, Logic Tools, had 3 different technologies. One for multi-echelon inventory optimization, a second for network design, and a third for production planning and scheduling. We sold the company in 2007 and became part of IBM. Pete and I have been collaborating now over 20 years. And about a year and a half ago, we started Opalytics, where I serve as the chairman and Pete serves as a chief scientist. Here is what we are planning to cover. We will start with an introduction to Opalytics, then give you an example of one application that was developed and uploaded to our platform. This is an application in supply chain risk optimization, talk about the model, talk about some of the challenges, and then show you some screenshots from the Opalytic network risk technology. And then the most exciting part of the presentation will be when Pete takes over and talk about end-to-end analytics development. Here he will emphasize some of the tools that we provide developers that allows them to develop and integrate their models and solvers in our platform. And finally, we will summarize some key takeaways. So let me start with identifying challenges that anyone who develops models, especially optimization models or statistical models, is aware of. First, you need to solve a unique problem. They may vary from a specialized vehicle routing problem to production planning, all the way to financial optimization and analysis. And a lot of time you will not find an off-the-shelf software to address the specific problem you are trying to solve. And as a result, you, with computer science and OR background, you try to develop your own model to address a specific problem at hand. But just developing the model is not enough. You are looking for processes and analytics for data validation, for testing the model. You probably would like to quickly deploy the solver and the model so that business user can start using the technology. And in fact, you would like an easy-to-use interface. You would like an ability to for the user to generate different scenarios, run the solver, and get an insight on business decision. You probably would like people in different parts of the organization to be able to use the same technology, and you would like to extract data from different systems, from perhaps the MRP system, from the ERP, or maybe some of the data warehouse that the company has, bring it to your model and solver, and allow the business user to make decisions. And finally, you may be looking for role-based access to information. Some people in your organization, some users are allowed to change the data, to change scenarios, and to run your model. Others may be only allowed to view solutions, reports, coming out of the analysis, and you want a technology that allow you to easily identify different roles for different users. This is what we are all about. We introduce to the market what we call Opalytics Cloud Platform, OCP for short, which is a platform that allow people like you to build analytic applications that drive business decisions. This platform has three important components. Cloud-based services like ETL services, file management, an ability to dynamically allocate different resource sources like solver and storage. I'll come back to that in a few minutes. The platform comes with off-the-shelf application. You're not surprised to see here multi-echelon inventory optimization, network design, segmentation, which is really machine learning techniques that allow companies to segment not only their supply chain, to segment customers, to segment product, or to segment suppliers. It's a very flexible machine learning capability that support multi-echelon inventory network design. And the last one that I'm emphasizing here, which is network risk. And I'll talk about network risk in the next few minutes. And then the third leg is the ability to integrate custom solutions. You may have your specific problem, you develop the model and the solver, and you maybe are using Gurobi as the solver. You want to deploy it on the platform, allow different business users to use the technology, and maybe you will deploy various models and solutions, all using same or similar data and allowing making business or operational decisions. Let me talk a little bit about some of the features provided by our platform. On the left-hand side, you see the various data that we can load to the platform, from Excel and CSV to ERP and BI. We provide, and I'll talk about that later on, we provide two different capabilities. One, an ability to drag file, for example, an Excel file, from your own PC to our platform. We also provide API, automatic API, which allows you to efficiently upload various files into the technology. Once you upload, we provide strong tools for data validation, geocoding, and solver identification. By solver identification, you may have multiple models, and our technology allows to look at the data that you uploaded and identify, yeah, this data is appropriate for vehicle routing and not for multi-echelon inventory optimization. In addition, we provide user management roles and authentication tools, ability to control and to manage scenarios, editing and validation technologies, and I'll show some of the graphics that we provide. But the heart of the technology is what you see here. If you look at my cursor, this is an ability to integrate your solver and deploy it in our platform. You can see that I have a number of parts of this slide colored by orange. These are the slides where these are the tools that we provide that allow you not only for data validation, for solver identification or geocoding, but also we provide a wrapper. We provide a set of tools that allows you to clean and test your model, but also integrate it straight to the cloud platform. And finally, the technology, the platform comes with strong visualization and reporting capabilities, including links to Click and Tableau, and ability to integrate with external systems. For example, you may be using your own model or our multi-echelon inventory model to calculate safety stock, and you want to feed this safety stock information into your ERP system so that inventory levels are set correctly in your business. There are three ways to deploy our technology. One is a public cloud. A lot of times this is for demo and just experimenting with our technology. private cloud where you have your own server on the cloud, and corporate. And by corporate, I mean deploy it within the firewall. So it stays within the company and it's not on the cloud. I mentioned strong visualization capability. One example will be you have one file that includes addresses of customers, maybe suppliers, maybe your own facilities. The technology has an automatic geo-coding capability that allows you to view the data on a map and to get an insight into the data sets that you are analyzing. You may have a complex bill of material with maybe many tiers, many levels in the bill of material. As the technology comes with visualization capabilities that provide detailed information about bill of material, where you can click on a specific node and identify which component it is, how many components are required, where it is produced, are there alternative suppliers. All of this is part of what the technology provides to any users to validate and view the data, and of course, reporting capabilities like the one that I am demonstrating here. But the key is that all of this comes as part of the platform, does not require you to develop your own visualization or your own data editing and validation capability or your own scenario management. And so with this introduction, let me show you how we deployed one technology on the cloud. This is a unique technology. This is a supply chain risk optimization technology that has been used by a number of companies in various industries, from automotive to pharma to aero and astro to aerospace companies. I am going to describe the supply chain model in the next few slides, and then show you how it was and the impact of the deployment of this model at a large automotive manufacturing company at Ford, and then show you some of the features and capabilities that comes with Opalytics network risk. But as you view this section, as you view the supply chain risk optimization and the detail of Opalytics network risk, think about this just as an example of a model that was developed initially outside the platform and then integrated into the platform and provides clients with an ability to identify risk and mitigate risk in their supply chain. And so let me start with some background on managing supply chain risk. When you think about supply chain risk, there are many sources of risk to consider. From what I call the unknown unknown, these are sources of risk from which you have very little data. As a result, difficult to build models, therefore very difficult to control. Examples include natural disaster, geopolitical problems, all the way to epidemics. On the other side of the spectrum, you have what I call the known unknown. These are sources of risk from which you have a lot of data, therefore you can build models. As a result, you can control them very well. Examples include market changes, supplier performance, forecasting accuracy, or execution problems. Controllable or uncontrollable, companies need effective way to identify risk and mitigate different risk in the supply chain. My experience is most companies do very little with respect to risk. We can talk later on if you want why, but they do very little with respect to risk. And if they do anything, they focus on the known unknown. Why? Because they can build models, and as a result, they can control them. But very little is done with respect to the uncontrollable. I want to show you here an example where you can build analytics to deal with the unknown unknown. Just a little bit more about the unknown unknown. The impact of disruption. These are low probability, high impact events can be devastating. Some companies realize that this is a challenge, and what they do, they visit each one of their suppliers to make sure that the supplier has the appropriate mitigation strategy in its business. if you're a company like Ford or you're a company like IBM where you have thousands of tier 1 suppliers, this is not going to be effective. By the time you finish this exercise, the supply chain has changed and you need a different strategy. So some companies understand that, and what they will do, they will use intuition and gut feeling to identify risk in their supply chain, and the intuition is telling them that risk is associated with high total spend suppliers. As you will see me going through the analytics, you will realize that indeed this is not the case. Indeed, risk is hidden in unexpected places. Only sophisticated analytics that allows you to identify hidden risk in the business. And so to illustrate our method and the optimization model, let's take just a small part of Ford supply chain. I'm looking on the right-hand side at the assembly facilities, and you can see that I have multiple tiers of supply, from stamping plant to engine plant, all the way to the chemical suppliers. Suppose you have limited resources and you're asking yourself, where should I focus in my risk mitigation strategy? Should I focus on the engine plant or should I focus on the chemical supply? It's hard to decide just based on looking at the supply chain, and so you may make decisions based on total spend. We want to do it in a more scientific way, and therefore I want to define a few concepts. The first concept that I use is what I call time to recover. What is time to recover? Time to recover is defined as the time it takes to recover to full functionality after a disruption. We talked to the chemical supplier, and the chemical supplier identified time to recover to be 2 weeks. Why? Because now they provide us with supply from a facility that they have in Germany. If there is a problem, they can switch to another facility that they have in China, and it takes about 2 weeks to switch to another facility and ramp up capacity. So time to recover is 2 weeks, and in a similar fashion, I can collect data on time to recover associated with each one of the supplier sites. Those of you who have been involved in supply chain or data collection and modeling immediately see that this is a problem. If I go to a supplier and try to collect information about time to recover, the supplier is going to be optimistic. They're not going to tell me the time to recover is going to be 2 months or 3 months. And so I need, as part of the analytics, a way to identify bottleneck suppliers. These are suppliers where information about time to recover is very important, and I need to work with the supplier to understand its time to recover and distinguish those from supplier where a plus minus 30 or 40% error in time to recover will have very little impact on risk exposure in the supply chain. And so I'll talk about that and the analytics in a few minutes, but for now, let's assume that I have the right information about time to recover. Once I have information about time to recover, I can determine what I call performance impact. What is performance impact? Performance impact is either financial impact or operational impact. Financial impact may be impact on revenue or impact on profit. Operational impact, an impact, for example, on lost production. The way we do that and where the optimization plays a role is I look at the chemical supplier, for example, and I remove the chemical supplier for the duration of time to recover. And I use optimization to identify how to allocate in the best way resources to minimize losses. And you can see that when I focus on total revenue, the performance impact of the chemical supplier is about $400 million. Because of the recovery that takes about 2 weeks, this is the impact on total revenue. And I can do the same analysis for each one of the suppliers, basically each time solve an optimization problem that includes the entire supply chain minus that facility or a collection of facilities that were disrupted. And you can see that when I'm doing it one at a time, I get information about performance impact associated with each site. All of a sudden, I know the engine plant is a problem, but it's not as much of a problem as the chemical supplier. If I need to decide between these two, I will focus probably on the chemical supplier. And in fact, the bottleneck is the contract manufacturer. And we use the bottleneck to determine risk exposure index, which is normalizing the performance impact by the maximum value. And all of a sudden, I have a ranking that allows me to focus on risk in this supply chain. And so let me just quickly summarize the benefit of using the risk exposure index and then go to the mathematics. It provides a dollar measure of risk. I'm not waving my hands. I'm estimating really the cost of risk. It's based on the entire network. Remember, I'm solving a large-scale optimization problem to identify impact on bottom line because of a disruption of a specific facility or a collection of facilities. It avoids completely the need to forecast the unknown. We already identified in a few implementations just collecting data on time to recover allow us to reduce risk because similar facilities report a different time to recover. When you try to understand how come similar facilities have different time to recover, you realize they use different processes. We standardize processes. It allows us to reduce time to recover and therefore risk exposure. And finally, it makes sure that we have a good understanding of supply chain dependencies because we look at the entire network. And so from the concept to the model. In the optimization model, each part planned combination is a node. And so you see here multiple nodes representing different components at different locations. Link represent transition between different nodes. Maybe it is within the same facility or across facilities. Detailed information about bill of material. And here is the optimization model. As you will see, there are before I dive in, two important components of the optimization model. The first is that it's a linear program, but it's a large-scale linear program. Not only it's a large-scale linear program, it also is required to run. We need to solve this large-scale linear program many times. So it's important to have an efficient algorithm, and that's the benefit of having an LP rather than an MIP. And so in this formulation, we are trying to minimize losses. As I mentioned, losses can be defined by the user, subject to a number of constraints. The first is bill of material constraint. What is a bill of material constraint? It just says that total production at a specific node, for example, node J, is bounded by volume allocated from upstream nodes. The second is on downstream node. It basically says that total allocation volume of a specific node, node I, to downstream facilities is constrained by its production plus the pipeline inventory. Of course, disruption constraint, and as you can imagine, it can be by node or by a collection, a cluster of nodes. Demand loss constraint, basically this says that the loss of production for a specific vehicle is bounded from below by the demand minus the production capability in the remaining facilities that were not disrupted. And finally, production capacity constraint, either at a facility level or at the production line level. And so we implemented this model at Ford. If you think about the automotive industry and you think about complex supply chain, this is an example of a complex supply chain. Large multi-tier supply network, complex bill of material. Just Ford itself has over 50 manufacturing facilities in this network. 10 tiers of suppliers, around 4,500 tier 1 manufacturing sites in over 60 countries, more than 50,000 different parts, and this supply chain support the production of about 6 million vehicles every year. And so you look at this and you ask yourself, where is risk hidden in this supply chain? And the analytics identify different level of risk. For example, the analytics, the optimization model that I just described says that out of the 4,500 different tier 1 supplier sites, about 2,800 sites pose no risk, expose Ford to no risk because there is enough inventories, because there are alternative suppliers. Whatever it is, the model identifies this as no risk supplier sites. There are another about 800 supplier sites that expose Ford to very low risk. But look at the right-hand side. There are about 400 supplier sites that expose the company, expose Ford to huge risk. You may ask yourself, so these are about 6,000, of the total supplier side, you may ask, who are these suppliers? Are these suppliers the suppliers where total spend is high, or are these other types of suppliers? Let's look. In this graph, and later on you will see that our technology provides these types of reporting capability as you run the optimization model. In this slide, you can see on the Y coordinate, total spend at a supplier site. And on the X coordinate, you see performance impact. To just protect for data, I don't show on the Y coordinate the specific spend by supplier site, but you can see performance impact on profit by site. And for example, look at these suppliers. This is clearly a high total spend supplier, but risk is moderate. Look at this supplier and this supplier. These two suppliers are supplier where spend is certainly higher than average, and I would say risk is moderate. The risky suppliers are at the cluster at the right-hand side. And you can see here all of them are low total spend supplier. In particular, I like the one on the right-hand side. This is a supplier where spend is almost zero. It's tiny relative to all the other suppliers. But this is the supplier that expose to huge level of risk. You may try to guess which one of the which supplier it is. This is a supplier of a tiny sensor that costs about 10 cents, and this tiny sensor is required on every vehicle. If supply is disrupted, you have to stop the production line. Very little alternative, very few alternatives as a result. Huge exposure to risk. And what we develop as well is an ability to segment the suppliers in order to also identify mitigation strategy. Remember the segmentation technology that I mentioned that comes with the platform. This is what we use in order to identify different mitigation strategies for different segment or different cluster of suppliers. I don't want to forget the question about time to recover. Remember, the time to recover is information that we are collecting from suppliers, and we are worried that the suppliers are going to be optimistic, and therefore we cannot necessarily rely on the information that they gave us. Let me remind you what time to recover is. This is the time it takes the supply chain to return, a facility to return to 100 capacity after a disruption. And so what we are trying to do in the analytics is to identify bottleneck suppliers. These are suppliers that are critical for where their time to recover is critical. And we need to work with the supplier to identify the true value of the TTR, of the time to recover, and distinguish those from other suppliers where even plus minus 40% error in time to recover will have very little impact on risk exposure. For this purpose, I want to introduce a second concept, a dual concept that I call time to survive. What is time to survive? Time to survive is a time duration where service is not interrupted until any disruptions. I remove a facility from the supply chain and I ask, how long can I match supply with demand without this facility? It's not zero because the pipeline is full with inventory, but the optimization model can identify this value. If for a specific facility, time to recover is smaller than time to survive, then for that facility is not a problem, because by the time that facility recovers, I can keep on matching supply with demand without any disruption. And if this is true for any facility in the supply chain, this is what I call a robust supply chain. And let's look at for data. This is again for data on tier 1 suppliers. On the X coordinate, you see time to survive in weeks, and on the Y coordinate, you see the number of suppliers, and you see the problem. On the left-hand side, we have suppliers where time to survive is very short. It's 1 day, 2 days, maybe 3 days. These are the suppliers that I want to work with to identify the time to recover. The opportunity is on the right-hand side. Right on the right-hand side, you see suppliers where time to survive is at least 30 weeks, 40 weeks, maybe greater than 50 weeks. Why is it so long? Because these suppliers typically keep a lot of inventory, or Ford keep a lot of inventory for these suppliers. can cut inventory maybe by 50% or by 40%, and it will have very little impact on risk exposure. And so in multiple implementations of this technology, we identify not only hidden risk in the supply chain, but also we are able to identify opportunities to cut costs significantly in the supply chain. This brings us to the third part of this presentation, focusing on Opalytics network risk. So I described the challenge, I described the optimization model, I described some of the concept, and now let's see how we integrated this as part of the Opalytics cloud platform. And so suppose you're an administrator, you build the model, and now you want to let different people use what you have developed. You can, for different people, you can define different roles. Either an author, somebody who can change input data, can run different scenarios, or a reader, somebody who gets report. And in the case of Ford, for example, Ford generates reports every day on changes in risk exposure by component supplier combination. And procurement people receive this report to identify, right, to identify potential problem in their supply chain. Think about this as changing the philosophy of running the supply network from thinking about KPI, key performance indicator, to also thinking about KPP, key performance predictor. I'm predicting where there will be an impact if there is a disruption. And so this is where you define roles for different users. Now, suppose I'm one of the users. I go to my folder. You can see that in my folder, and I may have multiple folders, but in this one, I have one folder that has 3 types of models. On the left-hand side, you can see 2 network risk models. At the top, you can see 2 multi-echelon inventory models that I built. And then you can see 4 different network design models that I developed. And so here is one user from the same company. Maybe this user is on the planning group within the organization. You develop models for the planning group, and they are using these different models to make different decisions. And maybe they run one model to feed as an input to the other. For example, you run the network design, and immediately this is fed into the inventory optimization because it requires changes in safety stock. Or you run the multi-echelon inventory, you calculate safety stock, and you ask yourself, what is the impact on risk? So the ability of all these solvers to reside in the same environment allow for not only analyzing and using one model, but also seamlessly moving from one question to another. And suppose in this case, I'm focusing on the network risk example, the bottom left-hand side model. If I click on this, you can see that I have different types of data in my model. Note, this is the combination of location, component, this is the location, a component combination that I use as node, the different finished product, the detail of the bill of material, demand information by product, production capacity constraints, transportation and arc links, whatever inventory I have in the supply chain, and various parameters that I need to use. This is also where you start changing the data. Remember, I gave you 2 different capabilities. One is you can drag files from your PC to the technology, to the cloud platform, or you can use our API to upload different tables to your model. Now, if I did not run the optimizer, you will not see anything on the right-hand side. Here, I run the optimizer with my data, and you can see that in the solution summary, I have various information about tables and KPI, including ability to visualize the solution generated by the The tool comes with very strong data editing and validation. In fact, we have two different capabilities. I will talk about one right now, and later on when Pete describes the tools that we give you, these are on top of the tools that I'm describing here. So you uploaded certain tables. This is the bill of, as you can see here, this is the bill of material table. The technology will search through different tables and generate error message. For example, you can see this red link identifying that this is a problem because you expect in the bill of material to have quantities greater than 0. And so it will identify missing links, it identify problems with nodes, and it identify bill of material problem. People who use the technology, not our people, but those who use the technology are telling us this is much easier and much faster to debug and validate. And once you do that, you have an interface for solver parameters. I'm showing here, of course, just the network risk parameter, but you will have your own solver parameter. So, for example, I'm focusing, remember that in the risk tool, we are focusing on identifying losses. Here, I'm focusing on revenue, and I can define various constraints. Constraint on total revenue, constraint on profit, constraint on cost, and constraint on demand or strategic inventory. All of this is part of the interface that you identify in the network risk model. If you have a vehicle routing technology that you have developed and you upload it to the platform, you may have the platform provide you with capability to identify whatever parameters required for the optimization model that you are analyzing. And finally, remember in the network risk, we not only focus on risk exposure index, but we also can calculate time to survive associated with each node. This is a result of another optimization model. In fact, not only does this give you information about time to survive, it has an important capability to answer the following question. Suppose you want time to survive and you see, well, there are nodes where time to survive is much smaller than time to recover. You ask yourself, where should I position strategically inventory such that time to survive is greater than time to recover for all nodes? This is part of what we can do with our optimization model. Solve the optimization model not only to determine time to survive, but also to position inventory effectively in the supply chain. And this is one example that I use. This is not the full data, where you can see a report talking, providing information about total spend versus performance impact. This is impact on profit. And you can see, again, like before, that the high-risk suppliers are typically the supplier where total spend is relatively low. And so at this point, I will pause and transfer the discussion and control to Pete, who will talk about end-to-end analytic development. What Pete will describe is some of the philosophy that we have behind the creation of the Opalytics Cloud Platform, together with the capabilities and tools that we provide you in order to integrate whatever model and solvers that you have with the platform. Think about this as like the iPhone philosophy, right? The platform comes with off-the-shelf capabilities, but in addition to that, it allows you to put your own solver and your own model as part of the platform. Pete?
Yeah, thanks, David. My name is Pete Gurobi. I'm Chief Scientist at Opalytics and longtime co-conspirator with David and Edith. I worked with them with Logic Tools for a number of years as well. So this section of the talk, we're focusing here on specific software development processes for building and deploying mixed integer programs. And there's a theme for this section where the overall theme here is connecting mixed integer programming practitioners with some broad and powerful trends in computing and data science. So the specific trends that I'm going to be touching on over and over again are cloud computing. I think that's sort of a given if you understand the basic architecture that we've discussed. So cloud computing, everyone is a programmer, and interactive programming. So by everyone is a programmer, what I mean is that people that have been traditionally thought of as data scientists are actually going to be doing more and more real programming as programming languages like like Python become more widely adopted. Interactive programming, if you're not familiar, that's probably the least known of these trends that I'm talking about. So if you're not familiar with interactive programming, you can look at projects like IPython or Jupyter. Jupyter is a superset of IPython. And the idea here is that for real data scientists, for people that want to move beyond the GUI and have real deeply powerful abilities to analyze data, the methodology that seems to work best is to program in sort of in sessions, to fire up a Python shell, load your data into the shell, connect visualization to your shell, and just write little micro programs bit by bit to study a piece of data. So these are sort of the modern trends that Opalytics is trying to, we see the business opportunity connecting mixed integer programmers and sort of prescriptive analytics in general to these three broad trends. So I see we're on the slide for challenges in deploying the solver. So if we look at this slide, we've got three broad points here that I'm discussing. These correspond to sort of crawl, walk, run. So there's proof of concept work. This is when you have a pile of data in front of you. You understand a business problem, and you think there's a mixed integer program in there somewhere. And so you don't want a lot in your way at this point. You want to have a very quick and efficient way of loading up a mixed integer program and seeing if it runs. The next step beyond that is to making a proof of, to go beyond a proof of concept. You want to make something that's more industrial, something that can be run repeatedly on a lot of different data instances and have it behave in a responsible way. And then finally, deploying to end users. This is sort of the run stage of when you have your solver running and you want to put a rich GUI on it and you want to have users share data. So I think the gaps that Opalytics sees in this space are with proof of concept work. There's traditionally been a question of should you use what language should you use? Like mixed integer program presents a wide variety of single-use proprietary languages, but Opalytics agrees with the philosophy of Gurobi that the most efficient route here is to use Python, and therefore to take advantage of a bigger technology stack that Python provides. The gap that Opalytics sees here is that there seems to be a missing library for separating the data from the solver module and for automating the process of creating simple, basic Python data structures. So people with Python, if they don't have a lot of Python experience, they sort of get stuck a bit at the front end where they're wondering what data structures do I use? Okay, do I have to dig down into this specific little library to read data? So there's a need for a library to automate those steps. For when you're moving beyond basic proof of concept and you're trying to make a more robust solve process, the need that we see there is the ability to efficiently check data integrity. So this is sort of what I see specifically as the biggest and least sexy, least recognized problem in mixed integer programming, is that mixed integer programming by its nature runs on tabular relational data that almost by definition will have complex data rules. I think it's really hard to formulate any sort of mixed integer program without using some of the language of databases and without recognizing that there's certain rows that can't be duplicated, there's foreign keys that match up, the data fields need to be of a particular type. All that checking should be done in an automated way. If you fail to do it in an automated way, if you fail to recognize the data problems before you plug your data into your mixed integer program, all sorts of problems can result. So the most obvious problems are the least dangerous problems, right? The most obvious problem is, oh, I tried to run my MIP and it crashed. So at least then you know somebody's trying to stuff a null where a null doesn't belong. But worse than that is if there's some sort of data reference problem, but it's subtle. So now your MIP runs and your MIP is giving you some kind of funny result. but you don't realize that your MIP is giving you a funny result because there is a problem in the data at the front end. So this is a big part of what Opalytics does. A big part of what we worry about is trying to automate the process of checking for good data on the front end. Okay, so the next slide, end-to-end analytics development. So this is the data process that Opalytics advocates. This is our response to the gaps that we see in the market. So the first and biggest response is that I referenced in the previous slide that there seemed to be sort of a missing library in the Python universe. So we've created that missing library. We call it TICDAT. That's kind of an amalgamation of Opalytics and data. If you Google TICDAT, you won't find it right now because it's not up in PyPy right now. It's TICDAT's. We're accepting beta users, and we're using it ourselves. We have, I think, 5 solvers up and running that are all using TICDAT for their data processing. But it will be up on PyPy. It will be Googleable surely before the end of the year. So what we advocate is that when you're at the very early stage, at the very beginning of proof of concept, you just use TICDAT to read and write your data, and you use TICDAT to define the input data and the output data format. So this really isn't adding any extra time because you need to specify your tables and fields anyway. Then when you move on to the next stage, when you move on to wanting to make your data more robust, you can use TICDAT to specify your data validation rules so that you're validating your data. So now that you've got a solver that can publish, can explain to some other module what kind of data it wants, now you've created a solver that can be easily deployed. So this is in general, this connects back to what I said about programming for everyone. This idea of you create a module, you create a numerical engine that recognizes the data format that it needs, and that results in a numerical engine that's easy to deploy. That's a good software engineering practice regardless of Opalytics. That's just sound software engineering that I think data scientists are going to increasingly, use the sort of principles that software engineers have been using for a long time. So, so deploying with the Opalytics platform, really the only requirement we have there is that you use Python and you read and write your data with TICDAT. I think David went through the cloud platform pretty well. So the cloud platform has rich visualizations. We can plug into tools like Tableau, or you can use Opalytics employees to customize your graphics needs. And then the step 4, so it's perhaps a little redundant to say don't forget the support, but I put that last bullet in there because I wanted to loop back around to one of my initial trends, which was interactive programming or interactive data analysis. So again, the idea with that is that the same skills, the same knowledge base you use to build your program is also the best knowledge base for analyzing the data that goes into analyzing the input data and analyzing the result set. So again, the nature of mixed integer programming, the nature of prescriptive analytics in general is non-intuitive results. Okay, if mixed integer programs were only used to produce results that made obvious sense, then we wouldn't need such sophisticated math engines. So it's inevitable that the results are going to look a little funny, and an expert's going to have to go in there and study the results very carefully to make sure that everything makes sense. And the added support that we provide is that you can use your same Python session that you use to develop your program, use the same TICDAT library that you're familiar with to plug directly into the Opalytics cloud platform, download data from the Opalytics cloud platform, and study it in Python in a manner to which you've already developed expertise. Okay, so the next slide. Okay, so this is sort of the obligatory graphic slide to give a break from all this technical talk. So on this slide, we're showing that the inner yellow circles would represent the Python code that you develop on your own desktop. The ovals, the more orange ovals around those would represent the wrapper that we plug on. So sort of that's sort of our private intellectual property that we use to efficiently plug to push TICDAT data, to pull and push TICDAT data back from the Opalytics cloud platform to your solver. And then you see the Opalytics cloud platform that is the data store, that is the GUI, and TICDAT data goes back and forth from the Opalytics cloud platform to each of the solvers. Okay, so we can go on to the next slide. Okay, so I've talked a little bit, I kind of referenced TICDAT before, but now I have a dedicated slide for that. So if I didn't make it clear before, it's clear now. TICDAT is a Python library that we've built that's dedicated to prescriptive analytics. I think it's sort of a if you're familiar with the Python ecosystem, you can think of it as sort of either a simplification of the database libraries like SQL Alchemy, like a vast simplification of those libraries, or you could think of it as sort of something like pandas, but simpler, more Pythonic, and more focused on tabular relational data. So what TICDAT facilitates is defining the input and output schema, defining the data integrity rules. It's also a data factory, so it allows you to make consistent data structures that just use basic Python. So that's what I mean by Pythonic. I'm not trying to brag about how Pythonic I am. I'm trying to say that the TICDAT data structures don't require you to learn a big additional set of technologies beyond just simple Python. If you understand dictionaries in Python, if you understand attributes, then you can use the TICDAT data. And the TICDAT data will be consistent with the names of your data. So in other words, the attributes of a TICDAT object, the table names are your table names, the field names are your field names. TICDAT allows you, we've added functionality to make it very easy for you to recognize data integrity problems on your desktop. We also, of course, we have our own proprietary technology in the Opalytics Cloud Platform for recognizing data problems and visualizing data problems, giving you a rich GUI. Our platform gives you a rich GUI with data problems, but you can also, our TICDAT library lets you recognize data problems within your Python shell. And then finally, TICDAT makes it easy to read and write data. So, I sort of, my original inspiration for TICDAT was just looking at what a pain in the butt it was to read Excel data, but also to read SQLite data, but also to read data from CSV files. It seemed like there ought to be just one library that if you give it a schema, it can read data that matches that schema regardless of the data source. And finally, I think TICDAT in general, it promotes good modularity of solvers so that solvers can be easily deployed either on our platform, in theory, on other platforms. I mean, it's not, but obviously we think we're the experts at deploying solvers that use TICDAT because we're the engineers of TICDAT. Okay, so now we're kind of trying to wrap things up here. I've got my last few slides. My last few slides basically go over the crawl, walk, run that I talked about before. First you build, the initial goal that people always want is they want to quickly build their mixed integer program without a lot of headache. And then after that, they want to run it robustly on a variety of data sources. And then after that, they want to deploy it. So this slide here. Learn 3 things to write a basic MIP model. This is all you need to do. This is how we feel we're contributing to simplifying the process of building MIPs with Python. So if you learn simple Python, you learn the basic data structures of tuples, dictionaries, attributes. You learn the basic flow controls. Learn basic flow control, and you learn how functions work. Then you're ready to. Then if you just learn those things, then you're ready to use TICDAT for reading and writing tabular data. TICDAT makes the objects for you. And it knows, it gives you a method for making data objects that have your table names and your field names so that it's easy to use those data objects. And then finally, of course, to actually run a mixed integer program, you have to use Gurobi Pi. So the part we're contributing, we feel our TICDAT library meshes nicely with Gurobi Pi. We're sort of handling the less sexy part that isn't specific to math modeling. But there is some forethought in making TICDAT as consistent as possible with some of the data structures that Gurobi Pi has. So, for example, a Gurobi Pi tuple list can be built easily from a TICDAT table. Okay, so the next slide. Okay, so this is so you need to learn 3 things to build a simple proof of concept, to build a more robust standalone pilot project. The 3 things you need to add are involving data validation. So these are all, if you read these slides, I'm using database terminology. My experience is that mixed integer programming people, they either know this database terminology or they may not be quite solid on the terminology, but they definitely know the concepts, right? Because if you've done enough mixed integer programming modeling, you've seen data problems. You've seen these data problems pop up and give you headaches. So again, the basic data problems are duplication of rows. For that, you need to identify the primary keys. And then once you've identified the primary keys, we have a good routine for recognizing duplicated rows. The next most advanced problem is foreign key failures. So foreign key failures are sort of like this is one of those relationships that exist between tables. So in a demand table, every customer in the demand table must be an actual customer in the real customer table. Every product must also match up with some record in the product table. So when those relationships fail, you'll have all sorts of headaches. So you want to check for those, make sure those relationships are sound before running your MIP. And then finally, defining the data types. So generally, the input data, the actual data fields are going to be numerical, but they should have, you want to be able to check their ranges. Some fields are nullable, some aren't. You can specify where nullability is allowed. And sometimes strings show up in actual data fields as flags. So, for example, when locating warehouses, some sites might be potential, some might be pre-existing. You want to make sure that the expected string flags are present, that there isn't any rogue strings in there that don't match up with any sort of flag. So the last slide. Okay, so crawl, walk, run. So I said add 3 things and then learn 3, or I said learn 3 things, add 3 things, and so remember everything. So this is where I'm looping back around to that concept of interactive programming. So it's easier to remember things if you use the same skills over and over again. Okay, human beings, it's fun to learn a variety of things. It's fun to sort of show off and play 20 instruments, but if you want to actually be a pro, it's better if you play the same instrument over and over again. So we facilitate using Python to support your tool as well as using Python to build your tool. So we and this isn't our, I'd like to say this is my idea. This is my idea. This is a much bigger idea. If you look at projects like Jupyter and Google Cloud Data Lab, this is almost exactly what the idea that Google Cloud Data Lab is doing. They allow you to launch a Python session, log into your system through a Python session, and download the data directly, so that you can, we're not saying the GUI is poor, but the nature of a GUI is what you see is what you get, which is another way of saying what you see is all you get. Okay, so this is why things like LaTeX were originally invented, so that you can use real programs, so you can use something more rich than just what you can do with GUIs. You can do something more like real programming to analyze your data and support your solver. So I think that covers all my bullet points. I'll turn the control back over to David for a wrap-up. Thanks for your time.
Thank you, Pete. Let me summarize very quickly. Think about how we can support you. And I want to emphasize 3 levels. Opalytics is all about empowering business analytics developers. We are letting you control the solver development and the ability to hook it up, to deploy it on a cloud technology. We provide strong capabilities for data management, for data editing, for model validation and debugging. And this comes as part of the technology, including, of course, the ability to visualize and therefore convince yourself, convince your colleagues that the models that you have built correctly represent the business problems that you are trying to optimize. And finally, the way I like to think about this, not only fast deployment to users who can apply the technology in different locations, but think about this as really light IT. This is a process where you can do rapid prototyping, employ it on the platform, and then allow users to start using it and giving you feedback and getting business insight. Let me stop here and we will take questions. Just one comment for more information beyond what you heard today. You can send us an email or you can go to our website. Chris, I will stop here. I know it took a long time, and I give it back to you.
Thank you, David. So at this point, I believe Edith has some questions, and so I'm going to that she can share and have the audience ask of you. So I will turn it over to Edith, and then once we're done with that, just to let everybody know, as a reminder, we will be sending out the slides, and the video of the recording of this webinar will also be available on our website, www.gurobi.com, in 1 to 2 weeks. So with that, Edith, it's all yours.
Hello, this is Edith Simchi-Levi. I want to address a few of the questions that I received during the call. I think probably the most important one is there was a question. I mean, do we build our own models or do we use the Opalytics models? And really, the idea here is that developers who are developing their own models will be able to deploy it to their customers. So that's that's really why we built this. And there was another question related to that, if we use Gurobi Cloud, and no, we use our own. So once you've developed this model, this will be loaded on our own platform. And this goes, because this goes a lot beyond just running a model. It's about having the interface for the users to run the model. So this is really the kind of closing the gap between somebody who's developing a model and getting the users to deploy it. I'm looking at some of the questions. And some of the more technical questions I think we'll ask. There was one question, for instance, if you have to manually import tables each at a time, again, and how we integrate with the ERP. We're using REST APIs, and we can integrate. You can either obviously it's easy to debug and do things with an Excel, but we can also link and automate this process, and we've already done that with one company, so that actually both the input and the output can be automated. The other and another question is, I guess, and this relates to how we deal with data in general, and obviously there's the combination here of being able to use the TICTAT to debug, and then using the capability and define the data, and then use the capabilities on our system to provide error messaging and an easy way to debug. And as Pete mentioned, this has already been used and is much easier than the systems we're used to in analyzing and running models. Another question for David. I mean, what was the experience with implementing the Ford?
So the question that Edith asked, if I got it right, is what was the experience implementing this type of technology for a large company like Ford? The beauty of what we describe here is that I can do all the development on my PC. When I'm ready to integrate, when I'm ready to upload to the platform, TICTAT provide me with easy to use capability, and this is really the opportunity to complete the deployment in a short period of time. The impact of this type of technology, of the network risk at some of our clients, is that the reporting is used on a day-to-day basis, especially the report coming out of the network risk capability. We generate a report, the system generate a report every day identifying a change in risk for different component site combination. And procurement managers receive reports associated with their suppliers. And this does not necessarily imply that something that you need to change your strategy, but it implies, as is the case in Ford, that because risk is increased, you need to understand why. It may have increased because inventory went below a certain level. It may have increased because lead times have increased. But all of a sudden, you have an opportunity every day to identify changes in risk. The second point with respect to this type of technology, it's not only used for identifying and mitigating a risk, it's also used as tactical and an operational tool. In the case of Ford, This is the example I gave you. They use the model, the optimization model, and the technology that we developed for Ford to respond to a disruption. The story that they told me was, if you remember, a few months ago, there was tension between South Korea. This seems to happen every couple of months between South Korea and North Korea. Procurement people at Ford were concerned that supply from South Korea will be disrupted. They use the technology to identify a high risk exposure suppliers and immediately develop mitigation strategy. My point is, once you develop a technology like that and you have different roles for different users, here is the opportunity to use it not only as a strategic and planning tool, but also as an operational tool. Back to you.
Again, thank you very much for joining us today for this webinar. We hope you found it informative.